Okay, so let's start building some proper figures with our actual data set. And for this, we start with histograms. So when you have data like this, where you have large distributions, you want to see how this looks like with histograms. I think that's one of the most useful ways of starting to explore your data. And what that reveals is, so what are histograms? I think most of you have come across histograms before. They basically show a distribution of numerical data, and by dividing the range of those data into bins and then counting how many values fall into each bin. So you can think of it as buckets, and then you see how filled are the buckets with the different data. And that gives you an idea of the central tendency of the data, the spread, see whether it's normally distributed, whether there are massive outliers, whether there's two peaks, whether there's a strange kind of distribution. So this is very useful, and we'll see actually already something interesting in our data set. The way to do this with matplotlib is you generate the figure arcs objects using the PLT subplots method. We can put in a fixed size argument here to say, how big this is in inches. So we want it 8 inches wide and 6 inches high. And then we call the arcs.hist method, and we are querying a single gene here, for example, the gene BRCA1. So all the data for BRCA1 will be aligned, and then we can see how many bins do we want, and we can play around with this in the notebook in a minute. So yeah, let's just go straight to the notebook, and then we'll also talk about this flatten method within the notebook. It's probably better to do it like that. So as usual, we call pandas and matplotlib, and then we will import the data. This will take a little bit of time, but we can already go through what we're doing here. So we are calling our data frame gene df here to distinguish it from the one that we did last week. So this is the first simple example of a BRCA1 histogram. So this shows you the distribution of the BRCA1 data. BRCA1 is relatively highly expressed gene. And we have the typical XY labels here. So this gives you a nice idea. So you see here, we have binned this into 20 different bins, and the figure automatically determines what is the lowest and what is the highest number we should use from the minimum maximum of the data. And then you see we have got, so we have our maximum is around 6, and we have a peak of expression around 5, between 4 and 5. So here is the peak of the expression, and the data look, they are not normal, they're skewed more towards the right, but overall we get a nice distribution of our data. So most of the cell lines fall around here. There's some outlier cell lines. Those are quite interesting. Those have very low expression of BRCA. So maybe these are BRCA mutants that have, have stopped expressing BRCA1. That's a possibility. But that's kind of the type of data you learn from a histogram. We could here separate the myeloid and the breast cancer data and generate 2 histograms by filtering the data and then comparing them side by side and overlaying them. These kind of data, that depends on what question you want to ask. But we're not here to explore the cancer data. We're here to learn histograms. So you can plot 2 different histograms side by side and or on the same axis. So that will overlay the data. So you see here a comparison of BRCA1 and P53. P53 is interesting. There's a lower expressing population and a higher expressing population, for example. But other than that, that looks all pretty similar. The alpha parameter here tells you to not to make this transparent. So if we were to plot this 1, then you would see that well, it still looks actually quite okay. I actually prefer it that way. But yeah, these things are things you can experiment around. All these methods have got quite a lot of different configuration parameters where you can change the style, play around with it. I would recommend you go to the Matplotlib website and to the documentation. And here you see all the standard parameters that we can use. Whoops, this has gone the wrong way. So here you can see all the standard arguments that we can supply. So we can put in density, can put in weights. So this is something you can play around with if you want to. Most of them are defined by default, but then you can change them if you want to. And there's a number of additional arguments you can use, but if you really want to get into Matplotlib, it's good to go back and forth with the documentation and also use Gemini or ChatGPT. They're very good at Matplotlib code, actually. I don't want to spend too much time on this, but go through the notebook in time. There's one important thing that I want to mention here, and I'm sorry things get confusing, but unfortunately, there's always, or fortunately, because you have a choice, there's always different ways of doing the same thing in Python, especially with pandas. And one thing that is worth mentioning here and also practicing is that there's a different way of plotting pandas data frames directly from pandas. So you can say df and choose the data, plot, and then kind line or kind bar or kind hist or kind density. And some of these things like density is much more tricky to do with Matplotlib. So there it's actually really worth knowing about the pandas plotting capability. So here's an example where we plotting the BRCA1 genes and we just do a histogram, and the rest is the same as the Matplotlib plot. So it's very similar, but you're just calling the BRCA1 gene here directly in the plot. And then you have to also, there's one more argument that you have to supply, which is the ax. So you need to tell the plot where to go. So you have to bring the initial figure ax object here in here and say the ax object here should be the ax. So we can call this axis, and then this makes it maybe more clear. We have to put it to the axis or something like that. If you have several axes, then which I show you later, then this will become critical to make sure that the plot goes to the right place. And one thing you can do now is you can very simply plot density distributions, which is basically a model of the distribution from the histogram, and that can sometimes be look much more attractive and nice than the raw binned histogram plot. It's really worth going into these notebooks, playing around. So we could increase this to 100 to make the bins a lot more, but that doesn't look very good because we don't have that many data in here. So probably let's make less. Whoops. So I broke something. What did I break now? Oh, there needs to be a second. And I think there needs to be a, oh, does that work now? Yeah, okay, sorry. So that's still with 100. So let's do 10 here. And yeah, you see that this has decreased the number of bins that we are pulling our data into. There's one last thing I want to mention. So there's quite a lot of work to do on the notebook, but this is a really useful feature to look at the entire data set altogether. So we want to look at what is the distribution of all data in our data set. And for this, we want to, first of all, just select the numerical data. And we used to do it with this filtering method, but actually a very simple way is just, you can say your data frame and then use the select dtype methods and say just include numbers. So this is a nice way of just selecting the numerical data in your data frame, and those are the ones that we want to plot in a histogram. You can't plot categorical data in a histogram, obviously. And then, so let's do that. And then now we flatten it. So now this is still a data frame, so it's still a 2D set, so we can't really do a histogram with that. So the flatten method works in that way. So we say our numeric df dot values dot flatten, and that basically now generates a long line of one-dimensional data with all the data aligned. So you see the total values is 1,500,000 and something. So that works well. And now we can use that to plot a histogram. That's what we're doing here. So after we flatten it, now we can supply this and plot a histogram. And here we see an interesting distribution actually, because most of the genes are actually not expressed or very, very low expression. And that's not surprising. Here we have all the genes from the human genome. So in breast cancer, you probably do not express some brain-specific genes or some testis-specific genes or things like that. So there's quite a large amount of genes that are not there. So if I were to analyze this data properly, I would probably get rid of this part of the data because they skew everything towards the low expression ones. So this is quite a useful thing to look at. One more nice feature in Matplotlib is, like, for example, if you want to highlight certain data points here, I want to highlight where the median is, although the median value is not particularly informative if you have such a large skew on one side, but that's kind of part of what that figure wants to show. We can use this ax vline method and then give it the mean value. So just all expression.mean generates the mean value, and that will then express in red on the y-axis here. Okay. So I think this is all I've got to say about histograms. Again, yeah, go through the notebooks. There's plenty of exercises in here, and this will help you learn this particular method. Matplotlib is not easy, and it's got so many possibilities, but start slowly and just build up your skills, and you have plenty of time to practice.